this input output. Okay, now just to be a bit, just to keep it a bit diagrammatic. Okay, so obviously in C you've seen the files std in and std out, have you not? Have you seen these files, or have you rather you have not seen these files, but have you used these two files, std in and std out? Okay, so how many of you have actually used these files? Can you tell me? That means in direct things, how many of you have used these files in directly? That is the business. That is the business in your programs and stuff. No, that is okay. But what I'm saying is, no. I'm not saying that. Follow my question. I'm saying who amongst you have used it directly. That means to say that how many of you have used it directly by calling on it? Hmm. I'm sure you have, but you've forgotten. Anyone else? Kostov and Ononna and Mriganko is there, perhaps, and Smriti. What about you guys? Yeah, but that uses STD in, and see, printf uses STD in, but and scanf uses STD. I'm sorry, scanf uses STD in, printf uses STD out, but that is not a direct use of it. Directly means that say you are using it. Have you ever used this function in files? Flush. There you go. There you go. So flush std in, you have used this to flush out the standard input file, and flush std out, so that flushes as a standard output file. So you see, that's the thing. So basically, standard input and output basically refers to the standard input and output devices are the keyboard. That is the standard input device, and the standard input file is related to that. Okay, and the monitor, well, normal monitor that the computer is connected to, that is this monitor here. Okay, yeah, so that's right. But Kaustubh, I would really appreciate it if you can please speak English when we are in class, so that will be very good. Okay, it's just that we are supposed to conduct this in English, and it would improve our skills as well. So please do that. Okay, and also there are people like Divya who may not understand Bengali, so that's the thing. Okay, don't mind, but I'm just saying that please use English, everybody. Now, so I hope you didn't mind Costa, but that is the norm. So please do that. Okay, so now standard input and from the keyboard in, and then standard output gives to the monitor. Okay, gives to the monitor. Right. So basically, the way it works does is that I'm just giving you the C model so that it is easy for you to understand. So whatever you are keying in the keyboard, all right, in the keyboard, that is the keyboard, and you are keying it in. Though those are actually obviously these directory signals, they're interpreted as binary signals later on. They eventually, through a series of things, they go to the std in file, which is then used for directing it to the programs and functions okay, so there may be various programs running, and they may have separate std in files, or several programs may be sharing the same std in file. So whatever it is, whatever architecture it follows. Okay, this happens now when you are wanting to, when you want to print something from your programs, then it comes out to a standard output file, and this once again, there can be one standard output file for all the programs which is being shared by all the programs, or it can be that one program contains, or rather has, its own standard output file dedicated. Now what the standard output file does is, obviously there is only one monitor. Normally there's only one monitor, and this monitor, this is this monitor which is connected to the CPU, and they actually give it to this. So this is the monitor, whatever monitor that is. Now that is the way it works. Now, why I'm mentioning this is that, you see, what are these standard input? What are files? Okay, files basically are named areas in memory which are used for storing data and records. Okay, so files contain data. Generally files contain data in particular formats. There are text files, and there are text files, then there are document files, then there are Excel spreadsheet files, etc. So these are particular formats of files. They contain data and the information with which we process the data. Okay, and obviously files contain, for example, C program files. They contain C program codes that you write, and we can distinguish the C program codes from the others because of the fact that there is there is this C program file with a .c extension. We know that that is a file, and the C compiler recognizes a file as a C program file by the .c compiler, and it tries to go into that. It won't parse a .txt file or .doc file or text file or a doc file. It'll go for a C file. It won't go for a Java file. It'll go for a C file. So that is how it actually normally, that is normally how it works. So but ultimately these are just areas in memory which are just buffers, basically, where some data and information regarding processing the data may be stored. Now why do we need these buffers? So you are keying it in. It doesn't mean that it will come in just like that into the computer. It takes some time. What happens to your keystrokes then? Say you are doing tap 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 tap, you're doing just doing that, you're just typing out in a speed of, let's say, maybe 40 words per minute or something like that. Then how is it that it goes straight into the computer? It is not always parsed as fast. There are so many different, you see, generally our computers are multitasking computers. There are several different tasks running on it, and it has to, if it, especially if it's a one processor computer, then it will have to cycle between the tasks. Okay, so if it's, generally it's a multitasker. Okay, and so basically it will be divided into various different tasks, and the tasks will have to again access input devices, then it will access some memory, then it will access some other peripherals. For example, if you want to write, if you want to, if you want the tasks to uh, just say programs, for example, to use some of the DVD drives, etc., it'll do that. And they may be writing on the DVD, it may be reading from the DVD, especially reading from it. I mean, there may be like several tasks reading from the same DVD. I'll give you an example. Let us say that you are running a program which is using, there is some sort of data available in an optical drive, let's say DVD or CD, and what is happening is that your program is actually using that DVD for data, but at the same time the antivirus software that you have, the antivirus software is also scanning the DVD at the same time. The antivirus software is also scanning the DVD for things like anomalies, because the DVD is an external thing. It is not a part of the system proper. It is an external storage medium. It's a secondary storage medium, as you may know, which obviously we'll cover when we do memory very soon. And it is used in a peripheral device. That is to say that it is the DVD writer or the CD writer or CD reader and writer that is being used for that purpose. And so all the time there is a risk that if something corrupted is there, it might come in to your computer and it may corrupt the systems. It may corrupt the other programs. So what will happen is a very typical scenario where there is a so your program is there. Let us say this is your program. It is running on the computer, and this is another program is that which is this is your program. So we will call it your frog. and this is the AV-Prog, which is the antivirus program. Now your program is getting its stuff from the CD. Okay, so this is the CD-ROM, and it is getting stuff from it. And the antivirus is also probing the CD at the same time using the same device, mind you, because obviously it's the same CD that it's working on. So let's say, okay, a CD doesn't look very nice these days, so let's just call it a DVD. In fact, those are also obsolete. I should have mentioned a pen drive, but never mind. Maybe I'm old fashioned. But anyways, so let's say that these two programs are actually accessing the same device. Now you see, they may not be writing on the same device. They may be, but at least they're reading from the same device. So they're accessing the DVD by address, and they're getting the data from it. As you may realize by now, that address is always one way and data is often always two ways. If it Yes, go on, Kostab. Sorry. Yeah, that's true. That is two ways. As I said, that is two ways, and the address is only one way is because address you need to send the address to the particular device so that it can be selected. The particular area or location can be selected for this data. But when the data is coming in, it comes in to the program that it is read. When it is read by the program, that is actually meaning it actually means that it is getting access to it, is reading it. Some way it is getting the data. It may directly come to the area that the AV program is using, or it may come to a specific area in main memory where both this and that data is using it from. I'm just drawing a logical diagram. The physical arrangement will be completely different to just this simplified state. It will be completely different. There may be several different stages through which the data is coming. Anyways, the main point is that here both the programs are actually using the same sort of medium for reading, and may also be from writing. If there is another program here, it may be actually using it for writing as well. Now take into account that there is only one CPU in the computer. So if it's a single processor machine, and it includes multi-core processors. Multi-core processors are just single processor with several cores, several ALUs. So if it's a single processor machine, it'll have to do all the work that is there. Normally how it happens, you just normally I'm just saying that box standard is just bring it from device. This is the input that is happening. Okay, so into memory, and this is main memory or registers. Now if you bring it into main memory, then you may also have to bring it into a register. Let us say if you are using it, then you this is the first step, and the second step to that is now redirect the data for the particular task, as in to say, for example, printing. So let us say that you are printing something from the device, and it's a printing program that is going on. How will it do it? Will access it, will get the data, and it will store the data, and then wherever it has to store it, it has to store the data, and then it'll just basically show it. This is what happens normally. I'm not saying that this is what happens normally. I'm just saying that this is what would have happened normally. But you see, this is a very big and tedious process. The processor is running all the other programs. You see, this program is run by the processor, that program is also run by the processor, any other programs are also being run by the processor. It's just a multitasking environment with a single processor. How does it help? Even if it's a parallel processing environment, but multiple processors are there can be many more tasks. Why do you have a multiprocessor? First of all, why do you have a multiprocessor? Does any of your computer have a multiprocessor, or are there multiprocessors? Any of you? No. All of you have got. You may have multi-core processors. For example, I've got this phone of mine. It's a Vivo S1 or S7, something like that. It's got an octa-core processor. There are 8 cores in this processor. Fine. Still, it's got one processor. So why would you have a parallel processing environment. When we say multiprocessing environment, in multiprocessors, not multiprocessing environment, I mean, I'm saying multiprocessing environment in multiprocessors, that is more than one processors available. Then we talk about a parallel processing environment where several tasks are divided, distributed among several processors. So you have a situation where there is a processor 1, there's a processor 2, then there's a processor 3, etc. And these all collaborate, and these all get some data from files or some devices. Okay, that may be external or internal. When I mean internal, I mean RAM, or external, I mean, so internal files, these are basically from RAM or any sort of main memory that you may be using. Okay, generally it is RAM, but any sort of main memory that you may be using. Or external files, these are all basically from devices and peripheral devices, peripheral devices and secondary storage medium. Okay, so for example, files in here will be the external files, but in case of file being in a RAM, that would be the internal file. Now the thing is that these processors get the data from several of these files. Okay, and why do we need a parallel processing? It is very expensive to build a parallel processing environment. Okay, it's not as easy also, because the algorithms have to be different, the operating system has to be set in that kind of a mode, and so it's all very not very cheap to achieve, both in space wise, both time wise, both effort wise, and obviously money wise also. Why do we have a parallel processing environment? Because we need many different programs that have to be run parallelly. Some high performance stuff is required. So as you can imagine that even if you have a parallel processor, it'll be such it'll be such a hugely busy environment, then again this kind of a thing will happen, that some processors will want to, or rather the processors will always be overloaded with some sort of multitasking. It may be that there are many different processors, but there will be some sort of multitasking they have to follow. So in that case, this holds there also. So there'll always be this condition where the input output or whatever is being held at ransom by the number of resources available. That means processor resources and the amount of work that has to be done, and how many resources want to access the same input output devices, and so on and so forth. Especially when it comes to the keyboard, especially when it comes to the mouse and the keyboard and etc. Just imagine, and the monitor. Just imagine there's just only one keyboard, one mouse, and one monitor in most of the machines. Even if it's a parallel processing environment, you don't normally have multiple keyboards attached and stuff. So what happens then? I mean, imagine even in a parallel processing environment. Okay, so in a parallel processing environment, so all these processors are there, but they're all being fed into it by one keyboard. Okay, just one keyboard and mouse, and also these are all feeding into just one monitor. Okay, so how is it possible? The answer to this is that input output controllers. Now you can look up into input output controllers in details in the net. Best way to do is if you can look up 8085 IO controller on the net or in Gaonkar. If you have Gaonkar's book, access to Gaonkar, it may be some electronic version may be available, because these days, because of the lockdown and stuff, many books are being done online, or online copies are being produced. In that case, you're in a stroke of luck. So it can be done. Look up the net, or net or Gaonkar's book. Okay. Look at the 8085 IO controller. Just read the 8085 IO controller in details to see how it works. Basically, I'll give you the scheme. So there is a processor here. I'm just talking in a very simple term. I'm just talking about just one processor. This is processor one. Now processor one it gives the input and it takes in the output, and it is being done or being it is basically, it normally gets done with the help of the input output controller. As the name suggests, this is a device. It's a peripheral device. It's a peripheral device. Anything which is on the periphery, around the periphery of the processor, the peripheral devices, it can be referred to as a peripheral devices. The peripheral device, okay, which has the important, a very very important task of connecting to, addressing and connecting to the input output. So let's say a one way, logically, so I'm just saying logically, let's say a one way data bus and some control lines to the monitor, outbound data bus, because obviously it gives out the data to the monitor. Now obviously, just don't think that this is so simple. There may be several different devices involved in there, several different memory levels, several different devices involved, programs, that is software and firmware both work on it, and this is how it is done. So when it handles several different programs, okay, the processor may just direct them to the IO controller, which may directly get the data from the programs themselves. Okay, so once the program asks for a an input or an output, the processor will maybe just relinquish control to the IO controller, and the IO controller will now deal with the program directly. Okay, so the way it works, and then there will be obviously a, logically speaking, a one way, I'm just saying logically, mind you, physically it may be quite different. An inbound data from input devices, let's say the keyboard and the mouse, okay, an inbound data bus, and definitely some to and fro. Okay, so now the control signals may not be just the inbound ones, there will be outbound ones as well, because the keyboard might need to control, send some signals, so those signals will be there. Okay, and the IO controller may need to send some signals to the keyboard, so those will be there, etc., etc., etc. Similarly, in here, there may be several different files that may be used by the IO controller, and in which case the memory space of the files will require some sort of addressing. In case of the input, standard input, also the keyboard signals may be buffered up in some sort of a file where uh, there may be, I mean, so let us just put in here the standard output. If we are talking about C, for example, standard output std out, that is in C, and here at some point of time there is a standard input file that is in C. Now what happens here is then there is a question of addressing the various lines in the, because see, this is just memory area, so there are various lines of data, and the input output controller will have to take the particular data and give it to the particular program. If, like, say for example, if two or three different programs are working, okay, so some output will be directed from program 1, some output will be directed from program 2, some from program 3, and the input output controller will have to handle that, because there is only one device. And when you are putting in some data, mm, that is normally easier, because you see what happens is, what do we do? For example, if we have, let's say the Windows environment, for example, let's say the Windows environment. In the Windows environment, so how do you actually, in this phone, for example, let's say that you are doing WhatsApp and Facebook. Now you're using the same keypad, obviously, but how are you going to use it? Obviously, you press on WhatsApp, WhatsApp comes up and you type something, then you press on, then you minimize it and press on Facebook, Facebook comes and you press something. So generally the context switching is being done by you yourself. But however, remember that whenever you are doing it, it doesn't mean that it goes into WhatsApp and Facebook at the same time. Obviously, there may be several different states of readiness of these applications by which, for which the data may not reach your application just when you are keying it in. But what happens normally is that it does, and the IO controller deals with that. So it gets it from some sort of file, for example, the standard input file, which is used in C. So it gets it from some sort of file like that, and it just directs it to the particular program. And the way this would work is that, let me just you know just in this corner. So if there is a program, so say program n requests IO to processor. Okay, processor so gives IO controller control. This is the sequence. Once again, this is very simplistically speaking. There are lots of different lines, etc., that are connected that goes on. For example, an input or an output sequence, when it is initiated, first of all, uh, it is first indicated that an output is required. And so when the processor finds out that the particular program requires the output, then it sort of readies it. So basically, it readies the controller for it. The controller waits for the data, and the data arrives. Now, this data that arrives, uh, it would normally, in a very box standard fashion, should have arrived through the processor. Now, it takes time, and it'll just hold up everything. So normally, what happens is when the processor just relinquishes control to the I/O device, I/O controller, the I/O controller can directly get it from the programmer. So once the processor directs the IO controller to service this program, it can give the IO controller the data, and this IO controller will then um, it'll just see whether it's input or input output. So obviously, what we're talking about is an output. So it'll send the output signals to the proper devices and files here so that they get populated, and in due course of time that gets shown electronically on the monitor. This is how uh, IO controllers are actually working. IO controllers actually work. Now, obviously, inside an IO controller, which is not a part of this syllabus proper. But you can look up, as I said, the 8085 IO controller, and if you do have any problems with that, we can discuss it. Not in the course of a class, but in a separate class, we can discuss it. So, if you look up the 8085 IO controller, you will get a very good idea of how it works. There are certain buffers. There is certain processing unit in the controller itself. There are certain buffers, that is the memory area, and it queues up whatever has to be output. It queues up, and then it uses the particular machine instruction commands to access the input device or the output device, and hence bring in the data, or just publish out the data. So that's how it actually works. So I do encourage you to please look up the 8085 IO controllers, how they work and everything, and tell me if you have not understood any part of that. It is most likely that you won't. Then we will discuss that. So I encourage you to do that on your own. Okay. So this was about IO controlling. Repeat which one? Repeat which one?